Now, from the preceding video, it might not be completely clear what I'm talking about, so let me try to clarify that. I wasn't completely satisfied with that explanation. I wanted to try to avoid what I'm going to do here, but I don't see a good way to do it, and I think this will help clarify. Okay, so we see we go from concavity like this to concavity like this. At least that happens between the concavity of the slope graph of the y factor 5/2 graph and the concavity of the slope graph of the y factor 6 graph. Okay, now we're talking about concavity of the slope graphs, not of the original graphs. Both of these graphs are concave up. But the graph of this concave up, the slope graph, based on the graph of this concave up graph, it wasn't concave up enough, and the slope graph is concave down. This graph is much more concave up, and that actually leads to a slope graph that's concave up. And you might think about just why that is. Now, we haven't really defined what we mean by how much upward concavity or how much downward concavity. And we can't really define that without some fairly, some first semester calculus, let's say. And we're not assuming that. So to understand the idea of concavity, just imagine these represent two roads. And you're going to drive along each road at some speed, a speed that's significant enough that even on this road you can feel the curve. Okay, you're not worried about losing your traction. You're not worried about hitting a slick spot and spinning out. You just follow that curve, and you can feel that you're on a curve. You're kind of forced toward the out. You feel like you're being forced toward the outside of the curve, pressed up against the door or whatever if you're in the passenger seat. If you drive along this curve at the same speed, you're going to feel that a lot more, and you're probably going to tend to be pretty worried about maybe spinning out, especially in certain parts of this curve. And that's not really totally a measure of concavity, but if you drive along the curves at the same rate, that actually does give you a measure of concavity. The other thing is there's not just one concavity that applies to this whole curve or to this whole curve. So there's some vagueness about just what we mean by concavity, but it's basically how fast does it turn. Okay, this turn curves about as fast as this one does, but this one curves down, this one curves up. So we're going to say that if a curve curves down, the concavity is what we call negative. So here's negative concavity. Upward, you got a positive concavity. The greater the positive concavity, the bigger the number we could put on the concavity, and the greater the negative concavity, the bigger the negative number we could put on it. There is a point between negative concavity and positive concavity where you have zero concavity, and that corresponds to, well, a straight line, doesn't it? Okay, so if we graph the concavity of the slope graph, concavity of this graph, versus the y factor of the original graph, the 5/2 here and the 6 here. The 5/2 would be associated with the negative concavity of this graph. The 6 would be associated with the positive concavity of this graph. So we have at 5/2, okay, so here is 5/2 on the horizontal scale, which is the y factor of the original graph. And here's 6, we've got that on there. So at 5/2, the concavity is definitely negative. And at 6, the concavity is definitely positive. Now, we don't know how negative or how positive because we haven't defined concavity. But if the concavity changes the way we think it does, in other words, if you increase this y factor a little bit, this graph becomes more concave upward, and the downward concavity of this graph will be somewhat mitigated. It won't be quite as downward concave. And if we keep increasing the y factor of this graph up to 6, we're going to reach a point where the concavity is upward. So somewhere between the downward concavity you get for this factor and the upward concavity for this factor, there's going to be a point of zero concavity, which would imply a straight line. Now, we don't know that that's going to be true. That requires proof, but we could say, okay, that maybe goes like this. Now, the question then is, what is the y factor for concavity 0? You could conjecture what that y factor would be, but we don't know how high this point should be. We don't know how low this point should be. If we do a straight line from here to here, what do we get? Something halfway between 5/2 and 6. If this point is as far below the axis as this is above the axis, well, halfway between 5/2 and 6, 6 is 12/2, that would be 17/2. You'd have, what, 8.5/2, which would be about 4 1/4. But, you know, there's no reason to expect that this concavity is as far negative as this one is positive. So we really don't know. So what you would have to do is construct a few graphs and test and just see where you think concavity might go from negative to positive.